Oh,
Uh, New red box. I don't know anything about that.
oh, I thought you just say that.
I don't think so.
Ah.
What would be new about it?
Oh, I thought that's for the MI 355 box.
Oh, that. I mean, yeah, I wonder, like, people are excited about those GB 300 NVIDIA boxes. I
Yes.
wonder if yeah, like, I don't know. I mean, so yeah, I did the math. It's like you're paying like 80% more for similar specs with half the power draw and better connectivity.
You can write CUDA.
Well, yeah, CUDA's worth something. Oh, I guess yeah, that's true. I don't know.
Okay. Anyway.
Um,
Okay. Star Wars company updates. Any other updates?
yeah, so Tiny with two eyes. You guys see the BoJack Horseman episode where they have Disneyland with two eyes? There's literally a BoJack about this. They probably stole it from that. Yeah, so we're suing them for trademark infringement, but only after they make money. So my plan is to wait for them to make money and then sue them and then take the money. So if any of this makes it back to Tiny with two eyes, hope you don't, hope you don't spend it too fast.
3x1?
A Tiny? No, it's a total scam.
Okay.
It's a total scam. They're okay. Have you seen like every once in a while these things hit Hacker News where someone will get like, I got Kimmy K2.5 to run on my iPhone. It gets 0.01 tokens per. It did a token. It took a minute.
Yeah, just use all your disk.
Use your disk. Yeah, exactly. So that's pretty much what this scam is. The thing has no memory bandwidth.
Mm.
Uh yeah. Let's see. We sold normal red box. We have two orders for green boxes, but they haven't converted yet. With a whole Hacker News thread. Tiny is spending a lot of money on advertising, so it's really just all going to flow into our pockets too. So we're winning on a lot of fronts. They spend money, we take their money. Big win. Yeah, we got two orders for green boxes. I'm trying to not order too many green boxes. RAM is up to $640 a stick. The RAM that we were paying $90. You do not want to get stuck holding the bag. I'm very excited for the RDNA 5 GPUs. I think RDNA 5 is going to be the generation where everyone accepts that AMD caught up to NVIDIA.
Great. Looking forward to that. I get a special deal when it's out.
Well, I'm going to speak at their. I agreed to speak at their conference. They agreed to extend our contract. I agreed to speak at the conference. Everybody wins. It's a win-win cooperation partnership. So we'll see if that extends to good prices on RDNA 5.
Sounds good. What's that?
That's it.
Okay. Cool. Next, Star Wars image 2 removal.
Yeah. Image 2 is gone. Yeah, pretty happy about that. It made driving vision and driving policy faster, although driver monitoring was a bit slower. Still need to look into what exactly is going on with that, but mostly seems like a win. Still needs to be moved to later in code gen, just to totally isolate that whole optimization. But I was looking at doing that. Seems doable. Yeah. Pretty good. What else? I looked in a little bit into getting it to work with IR3. Some like latent bug in the way that we were handling textures for IR3. So it also works. And we also get good performance there. It's like marginally worse. It's like a couple fractions of a millisecond slower in driving vision.
Wait, so IR3 is the Mesa.
Yeah.
And it works.
It does.
Cool.
Yeah.
A couple milliseconds slower. That's a lot slower.
No, fractions. Like tenths of a millisecond. Like it's like 0.2 milliseconds.
Oh, that's almost worth it just for open source.
Yeah. Anyway, I don't know. I thought I might throw that into the benchmark so it doesn't have this sort of latent bug in it. Like,
I mean, I'd much rather, if the speed is comparable, I'd much rather use Mesa than the closed source one.
yeah. So, anyway.
Do you have the LLVM running in the? Yeah.
No.
I'm curious what the LLM looks like and how much we're gonna have to like stub and stuff.
It looked pretty normal.
How are they doing images?
So they have it like call a function called like
Yeah.
QCOM read image or something like that.
Yeah, so we can just can we just implement QCOM read image in like 3 lines?
Yeah. Yeah, so I gotta try that out, but like it should just work. I mean, I haven't tried like every single edge case. Like I don't know, like maybe when I call sign, it does some like weird thing, but like seems like it's probably fine.
I have a small thing for image. So for now, because if I try to run the command, we have that command that checks how many image reads are there with the allowed image read thing. If I just run that command on Mac, it will fail because Mac picks a different value for image filtering, and that's slightly annoying for development. Can we do something about that?
Yeah, so I mean the issue here is that the image shape requirements are different on Mac than they are on Qualcomm.
Yeah, but if we use the same as the Qualcomm one, is it just like fail to compile or slow?
Yeah, it'll fail to compile. Like you cannot create images that are the requirements for the image shapes are different.
Well, if it failed to compile, it should just not use image.
Oh yeah, but if I were to try and tell it to use the same shapes, it would wouldn't even. It's not that it failed to compile; it would fail to run because we break the images on the fly, and like that's not a valid image shape.
Yeah, there's like certain strides that are just enforced by the hardware and the texture sampler. They're different.
I see.
Yeah,
I mean, you can see that way. This is annoying. I don't know. Yeah,
it definitely is.
Can this work with the null backend? Is there a way? I just want to be able to run this locally on a Mac and see how many am I like regress the image read.
Yeah. Let me think about that. So maybe the null backend with IR3, we could find a way to get the number of image reads through IR3, the Mesa stuff, because
Wait. Why do you need a renderer in order to get the number of image reads? The null backend.
Yeah, I guess that's true.
You shouldn't need a renderer. Yeah. If you're just looking for the number of image reads, that should work with null.
Yeah.
Yeah.
Okay.
Maybe
Well,
that's...
we should have a different way of counting it. Yeah. That should be fine.
Okay. Anyway, that was my small thing because I can no longer run the same thing on Mac.
Yeah. No, I get it.
Wait, could you ever run the same thing on Mac?
What do you mean? I always developed previously on Mac.
What's changed? Mac always had this limitation. The sizes were always different.
It's that it would. Well, yeah. Actually, this probably never worked with image 1.
Yeah, I mean,
This may have worked with image 2.
No, but how did it work
previously with image 2? It worked, right?
Because it just pads the pitch.
Why can't just pad the pitch?
I
I don't understand why it regressed. Right? Like whatever shit the hardware had to do is still true.
That's true. Yeah. No, yeah.
So just fix it, right? So you're saying like what you need an if statement of tensor to say if it's Mac, do this.
Yeah. Okay. I don't. It seems annoying, but I can just do that.
That seems like the right place to put it.
Right? Okay.
Yeah.
Yeah, that also makes sense.
No, we're going to restore. If there's any regressions from the image equals 2 behavior, there shouldn't be. The only problem is that the shapes are actually internally slightly different.
Yeah, so if we can just even if it's the debug flag, I think that would be helpful. It's just to understand.
No, I can just restore the same behavior, but with a if statement and okay.
Sure. Yeah, because obviously our goal is whatever we put on the CI and which machine we pick, if we can run that, it should pass. So
Yeah.
okay, cool. Anything for the target triple thingy?
Yeah. You just have to think about like the problem with having it being an environment variable like target is in the case where you have, for instance, like multiple devices that you're so for instance, like I'm gonna run something on the Qualcomm GPU, but then I'm also gonna run something on my AMD GPU that's plugged in over USB. And how do you specify that like, oh, I want to use AMD LLVM, but I want to use Qualcomm IR3? Um, that's the one I think maybe a little bit tricky case. And then also like there's always just a little bit of weirdness around how you're going to use null, but I think that's resolvable.
So I think the answer to that is targets, right?
Mhm.
And then you have your. Did you write this user story somewhere?
Yeah.
Okay. Yeah. We'll go through them after the meeting. Yeah, I think the idea is basically you have the place the memory lives, the renderer, and the uh like the renderer args, right? Memory, renderer, args, and like you can associate different memories with different renderers.
Mhm.
I mean, we can figure out also if we want to be able to like do some things with one renderer and some things with another renderer. There should be able to be a context bar for that.
Yeah. I'd say that you have like one environment variable like targets, and then it's like Llama separated or something like this.
Maybe. I don't know. I have to go through that. And we're gonna go through the user stories
Yeah.
and then back solve for what the semantics should be.
Yeah.
I think we already know like there are some places, some existing stuff we want to remove, and there are something we want to do, but currently very hard to do, and then just combine that. I think it's fine not to get this right in the first time, but every incremental change should benefit the users.
Yeah.
Cool. Anything else?
That's it. I think. Yeah, that's everything.
Move on to Georgia stuff.
I mean, there's a change I want to think about there, which is like when you have the AMD device, it's just all the GPUs. Right? It shouldn't be like you can't select AMD 0, AMD 1, but let me figure that out. 'Cause that's another question, right? You have the memory, and then like you split out the memory.
Mhm.
And we don't split out the memory for the CUs, so why should we split out the memory for the VGPUs? Then there are also compute devices, so something. My stuff. Yeah, I wrote been on the board for a bit. It's like write flash attention with the new stuff. So we have a pretty flexible AMD flash attention that outperforms Torch. And it doesn't just outperform baseline Torch. It outperforms Torch with the secret flag. So baseline Torch is terrible. Baseline Torch isn't flash attention. If you want flash attention, you have to put the special Triton enable flag, and then you put that, and we're beating it by 1.8x on Strix Halo. So, and that's still also pretty unoptimized. I did have to write the warp shuffle thing, but I mean, Claude had to write it. But the LLMs are quite good at using our API too. They're a lot better at using our API than they are at writing assembly, which is good. I think there's just a lot more cleanups there. I'm figuring out like how to remove ranges. I fixed a bunch of bugs in indexing, fixed a bunch of bugs in the emulator. Just kind of moving toward having a set of kernels for AMD, really for Strix Halo that are fast. I'm real excited about the Quen 3.5 thing. Yeah, I mean, if we can be the place where you just pip install tinygrad and then it runs Strix Halo, and then it runs Quen 3.5 fast on your Strix Halo, that's pretty good. I think we can get a lot of users with that, or some users with that. Also, I spent the morning playing with VLLM and SGLang. And I tried it really the best way I could. Like I didn't mess around. I tried the AMD Docker, the exact way all the docs say to. SGLang doesn't work. VLLM gets about 35 tokens per single user. Terrible. Like all of these, the theoretical is 2,000. Like fine, you're not going to hit the theoretical, but can I at least have like 200? Like I think there's a real lack of high speed single threaded LLM runners, which is kind of what you want. Like what the individual wants, what I want, what would get me to not use Claude? Claude gets me like 40 tokens per second. If I could have Kimmy with 400, I don't know, it might be better. It is cool. It's stood up on, I posted in the TinyBox Access channel. If anyone wants to use it, you can just access it from inside our network. It's a VLLM server, so you can like point your open code at it or whatever. Point your open claw at it. And yeah, I mean, I want that to be like a good experience. I want to have something that we can offer people, starting with people inside the company, hundreds of tokens per second. So yeah, I don't know how we get that yet, but maybe through writing kernels, making them all work.
How well is this testing CI?
I will what be tested in CI?
The AMD flash attention.
Oh, it works. Yeah, I can add it CI.
Yeah.
The emulator works.
Yeah, add something because I'm working on the broadcast thing and I just look through your examples, finding the things you probably want.
Oh, great. Yeah. It's just Moxie Buell is one in the thing. I'll add it CI. I'll make sure both my AMD flash attention and my AMD gem.
Yeah, the copy something.
Copy what?
There's one called copy memo or something.
Yeah. Copy Matmel is the new one. I think Asm Matmel should work in the emulator too. So Asm Matmel is still 80% faster than copy Matmel. Which most of that gap has nothing to do with most of that gap is LLVM issues. It has to do with how LLVM poorly schedules the loads. So we have to go to assembly if we want to get that performance.
I see.
Yeah, I mean, there's a lot to be gained just by getting the memory correct. Yeah, and then like we sort of have this distinction between, I'm drawing more of this distinction. This is like the image equals 2 thing. I'm drawing more of a distinction between the first half of the kernel generation, which is memory, and the second half, which is code gen. I also realized that like the expander, the real name for it is derangify. So we have like rangify and derangify, and I think we can write much simpler versions that basically like now I understand what they are. Yeah, I got to work on
What's the rangify?
expander is derangify.
Then maybe what is rangify?
Rangify, if you have a shaped tensor, rangify removes shapes from the tensor. There's full rangify and partial rangify, but if you do a full rangify, it removes all the shapes in the tensor and everything basically has no more shape in it, and then it has ranges. Derangify or expander lets you take a range and insert it back into the graph. And that's like an upcast. So you can do this like, yeah, taking and removing ranges. But the ultimate goal of this stuff, and hopefully what'll be done in maybe like 6 weeks, is the removal of D-type vec.
Yeah. Oh, that sounds good.
See why Kimmy's bad.
Anyway, anything else?
Nope.
Okay. My stuff. I was mostly doing cleanups between the Tensor and UOP. So Tensor constructor should be a lot cleaner now. A lot of logic that we previously have for index, now it's called weak int, is being there's a function called tensor.from UOP. Now we have a single coder that calls that. And I was looking into how to, like, what of the broadcast to move to the common mixing, because Tensor for now does a lot more than UOP. Tensor does the D-type upcast. So if you add a integer tensor to a float, small float, it will upcast to the common upper D type. We don't do that for UOP. For UOP, it just inherits the type from the UOP.
I think we should.
We should do that in UOP.
Yeah. I think we want all the broadcasting in UOP. I think that so we were going over here on some ways like to talk about what the specification is for functions. And like I coding at the UOP layer is a lot nicer than coding at the tensor layer. And we want to bring all of the niceties from tensor into UOP. So I don't think there's anything that tensor should do that UOP doesn't do, except for things that are stateful.
Or the things like tensor can create a tensor from a UOP, right? There's no such thing as UOP create a UOP from a UOP.
Yeah, tensor can create a UOP from a UOP, but even then,
Tensor can create a tensor from a UOP.
Yeah, I don't really understand this. I don't understand why that function exists, a from UOP function. Why can't you just like a tensor is just a little container around a UOP?
Because we also use UOP in a symbolic shape.
That's fine.
Okay.
It'd be fine. Basically, I want to make tinygrad completely programmable at the UOP layer. The only thing that the tensor layer gets you is mutability.
Okay, I mean that makes sense. I will think more about this, but I think generally making the tensor thing, making the things that specific to tensor smaller seems to be the direction we want to go. So
Yep. Yeah, like cleaning up that flash attention to remove all the ranges from it basically is when all the ranges are gone and all like the extra reshapes and expands are gone, then we've reached the point where like UOPs are very programmable. Like we kind of have these two APIs and we're coming at them from both sides. We like unify them, right? Like there's a tensor API from the high level. There's this like UOP kernel, like you can use it to code flash attention, but those things should be unified. You should be able to basically write flash attention in tensor. And I think that's the answer. I mean, I think the answer. Oh, I have two things that I think I now have answers to. One is this, like, how do we auto discover flash attention? How do we auto optimize flash attention? We don't. Finding that online max is not a transformation that we should ever put in some auto magic shit. Like, if you want to do that, just code it by hand. And we should just make the API to code that as simple as possible. Because that online max is not a, like it changes the computation.
what about Winograd?
Winograd, so it's similar. It's similar, sure.
Yeah.
If you want to have Winograd and online max are basically the same thing, and you can have these as these like light post-processing layers after tensor. I mean, they can still be graph rewrites. My point is they aren't kernel optimizations. So yeah, I mean, yeah, obviously they can still be like graph rewrites, right? We can have some high-level API that then like goes and pulls out things that look like attention and things that look like oh, this will benefit from online softmax. This will benefit from kind of in the same place we have split reduce op.
Yeah, that makes sense.
Yeah. So I think they can be rewrites, but they're not opt-ops.
Yeah.
And then the other thing I realized is we always would talk about some way to do like, okay, so we have Beam and Beam is slow. What we want is Beam to automatically discover heuristics for a system. And I think we have now been given the thing that does this. I imagine heuristics becoming a big directory, like a couple thousand lines, but it's all LLM generated and it's all like simple. It's all like it has a very narrow API and a very clear definition of winning. And then when you want to add a new accelerator to TinyGrad's heuristics, we have some big set of kernels. We tell an LLM, find heuristics that do this stuff. You're welcome to use beam search. You're welcome to use whatever. And then this solves the problem of like, how is it just fast out of the box?
Makes sense.
Because I think we'll never be able to build something that's generically good. There's so many little bits of subtlety and nuance. We just need to.
It always feels like you need at least a very thin layer of search. It's just you can make that pretty fast. We have more and more stuff look like now in the earlier past. We use different proxies to pick some options.
Yeah, and like the new heuristics, one of the option can be search. But the heuristics the LLM finds can include, we can give it a budget. We can say you're allowed to run and benchmark 3 kernels.
Cool.
And then it'll make some big mess of 1,000 lines of if statements, but who cares? Because the API is really narrow.
Yeah, so it's a decision tree, and it's also easy to read from LLM. So
yeah, it's an LLM built Python decision tree.
great. Okay. One last thing I was thinking about was the weak int. So I renamed the dtypes index to weak int. It will probably work very similar to Jack's weak int. So this is also tied to the type promotion stuff in the broadcast. So I want to like think through this. But the idea is we now have some custom rules saying what this int type should do. And basically, the idea is if you got a Python int and you have a tensor or UOP acting on that Python int, what dtype should that be? So currently, we have 2 sets of different rules: one for tensor, one for UOP. We might unify them to the single one, but still, the idea there is you can decide the type of any objects from Python. You just need to know if it's a float or if it's an int, and you can decide the concrete actual type in the kernel much later if you keep those as weak int. For now, if you look at the tensor init function, we pretty much just put default float and default int for them and go from there. But you can imagine a world that those are determined later.
Makes sense.
Yeah, so thinking about that will solve some weirdness in terms of like int64 plus uint64 becomes a float 8. Also, we have like a lot of different float 8. I also want to think like how to unify these better.
Yes.
We previously had some priority thing, but now people just we have priority 0, -1, 800 or whatever. So it would be nice to clean these up.
I don't know about the priorities, but I certainly know the way the float 8 should be unified. So I think so we have those like 2 float 8 types, one for NVIDIA and one for AMD, and they are slightly different. I don't think we should track those as different D types. I think that's just something that's done at code gen layer, and we're kind of just indifferent to those things. You have to just kind of know. But
that's tricky because that also tied to how you want to use this. If you write a custom kernel and you really said for the forward I want this one and for the backward I want that one, you need to be able to specify that using D types.
Yeah, absolutely. But there are 2 real types, and the 2 real types are FP8 and BF8. There's not 4.
It's probably also more than 2.
Pretty sure it's 2. Everything pretty much talks about 2. There's FP8 and BF8.
Yeah, there's only 2.
2 on the hardware or 2 in the concept? Because people also talk about the one that is all.
As far as I know, people only use 2.
Yeah.
There's the 4-bit exponent one and then the 5-bit exponent.
Yeah.
How about the O exponent one?
I haven't seen anyone use this.
I feel that's the new thing. No, I don't know. Okay, anyway, I think keeping 2 makes sense. So we'll think about that more. Yeah, it'll be nice. Once this is cleaned up and back is removed, D type can be small and clean again. That would be really good.
Yay.
Okay. Next, Llama training. Let's fly Llama.
So flat llama is integrated. Apply grad doesn't train.
What do you mean apply grad doesn't train?
The grad is 0.
What grad is 0?
The grad on anything on most of the tensors that are not on the immediate output layer is 0.
Let's apply grad. So there was some bug in my stuff?
Yeah, your apply grad function that saves memory on the backward.
Oh. Did you
Yeah.
fix it or did you remove it?
No, so right now I'm just training with backward. I looked at it a bit and then I couldn't fix it.
I see, but you are using flat.
Yes, I'm using flat llama just with backward.
That should be fine. Yeah, we just need to add in that hack and do it properly. Backward should be fine. Just make sure that you're cache hitting by the second time.
Yeah.
Yeah. Also, wait, 7 hours, 41 minutes is the best time we've ever gotten? Really?
Yes.
I thought we had MFUs that were like over 20.
Yeah, but this is actually lower MFU, but it actually converges in the correct number of steps.
And wait, you had to put floats in FP32?
Yes, FP32 master weights with FP32 optim is the only way I got this to converge.
But the weights on the GPU are still 16?
Yes, so we cast down for forward.
Wait, the weights on the GPU are 32.
There's a copy in float and a copy in bfloat 16.
On the GPU?
Yes.
We gotta fix this.
I'm trying stochastic rounding as well.
Yeah. Wait, but how did this get worse? Didn't this used to work?
Yes, but we weren't following MLPerf reference in it.
Oh.
So now that I've implemented reference in it, because on the output layers, the residual is scaled down so that the residual path stays the same throughout the model. And then because that update is now really small, it goes outside of bfloat 16 precision. And the model stops training.
Can't we just like scale this? So
we could potentially, but as far as I can tell, the way that everyone does the training is FP32 weights.
FP32 master weights
Yes.
that you run the optimizer on.
Yes.
You need M and V in FP32 as well?
Yes. I tried without and it also diverged.
Where are we storing those?
Also on the GPU right now. For 8B, everything fits.
For 8B, everything fits, sure, but wait, is this training done with MP or DP?
DP.
It's a DP.
Yeah,
It should
8B is DP.
AP is DP. Yeah, we should be testing more with MP too. How much
Yeah,
slower?
I saw the contract was extended and then so that we wanted to submit 8B for this.
We want to submit AP, but we need a much better time than this.
Yes. So I want to get 8B at least submittable because right now our 8B is, there's still some stuff that is missing.
What's not submittable about it right now?
Just weight in it.
Oh, so but this new one was with the right weight in it or not with the right weight in it?
Yes, the new one's with the right weight in it.
So this new one's submittable.
Yeah. Once I add logging, I need to add output logging.
Sure.
And add the logging and add the script so that we should have a one clean script that just by repeating running it, we will have a submittable artifact.
Yeah.
Okay.
So they got 122 minutes. Can we beat that?
can try. So WQKV on 8B hits a very bad gem shape, and it's very slow.
We can disable WQKV. If
Yeah,
we have.
so I just added a toggle for it, and then we can split it.
Yeah, 100. We got to get 2 hours.
I think adding logging and adding something like a benchmark so that people can easily see what's slow helps, because then whoever is interested can like improve something.
Yeah, with the benchmark script, like benchmark equals 5 or something. It's all pretty fast now too, right? Like it boots up real fast, right?
Yeah.
Right. Oh, you're using flat transformer. Did you pass anything on the backwards?
Or
You just-
passing it.
So the backwards is okay. So the function, the
Yeah,
function
I've tried with function and without function.
was this training run with or without function?
This was with function.
Okay. So is it faster without function?
I believe last time I tried it, yes.
So what you want to do is keep function, but you want function to return intermediates, and then it'll use those intermediates on the backward pass. See what I mean?
I see.
Yeah, so currently if you use function, it will just use only what's returned from the function in the backward pass and recompute everything else. But if you return some intermediate stuff, you're trading off memory for not recomputing, basically. We should have lost the memory.
And I don't have to use these, I just have to return them.
You don't have to use them, yeah, you can just return them.
Okay.
That should work. If it doesn't work, I'll into it. But yeah, it should just work.
Okay.
I think it's also nice just post whenever you have a run or have like some config in the channel, so you don't need to wait for the weekly meeting to update on this.
Yeah.
Okay. Next, the new remote JIT planner thingy.
Yeah, so remote is merged. You need to use the variable remote and your IP port. So for the new JIT, so the current implementation is we change the current JIT to collect linears, flatten these linears, and run the new memplanner. So for the JIT 2.0, I think we should solve a sign-in function problem. Yeah. Mostly that's the problem. We actually have tests already, which with the wrong behavior. So I think we should fix this.
So I think before we do a sign and function, we have to make the graph. We have to remove the graph from the jet.
Yeah.
We talked about it. Yeah, we came up with a plan for new JIT, and you basically like get into what the old JIT is. The old JIT is like a memory planner and a graph and a kernel capture. So we can pull out the memory planner and the graph, and then the kernel capture is just okay. That's what becomes function.
Yeah, I'll do that next. After the
Great.
memplanner on.
Yeah, good work on the mem planner. I didn't look. How does Viz? Does it Viz show it nicely?
Oh, yeah, it does show, but it's pretty like on the
Okay, don't work. It's pretty laggy.
yeah, relatively right.
Let's see what we got. This is so slow. Why did my computer crash? I crashed my GPU doing this. I don't know. Okay, so it's in schedule. I can find the memory plan. Oh, these are all pointing to a buffer. Oh, cool. Yeah, so there's something you'll see on schedule now. Oh, those are all the same view? What's that doing? I'm just stepping through memory planning. Oh, cool. Yeah, that's great. I can work on local stuff. The other thing, talk about GMMU.
Oh yeah, which is disabled gaming view to make USB cluster.
I mean, I think it points to even more like TinyGrad long term will have the ability to just not have an MMU. MMUs are slow and have TLB misses, and like you only need one if you did a bad job centrally planning. Yeah, try your GPU without an MMU today. GMMU equals 0. AMD only?
No, both.
Works on both. Really? And the NVIDIA, like, it boots fine without the MMU.
Actually, it's like identity mapping.
Oh, you did identity mapping on NVIDIA. Okay.
Basically, actually, the biggest limitation is that you need to access both. Like you need to specify your access, like if it's cached or not. And the
Okay.
only way you can do this is with page tables.
What's the default?
I mean, you can set this.
No. But what if I turn the MMU off? What's the default?
So we have identity mappings.
No, what if I turn the MMU off? Is it cached?
No, you can choose. I mean, on AMD, you can choose.
On
If
AMD,
it's uncached, if it's cache coherent, if it's not coherent.
on AMD, you can choose at what level, like the instruction chooses, right?
No,
In the page table.
globally.
Oh, globally.
No, you can choose globally, like for the whole, like the aperture.
The whole, okay, for the aperture, that makes sense. And then what about for NVIDIA? There's no way to choose?
Oh, I don't know. But yeah.
So, interesting.
Anything else?
No, I think Melanox kind of works. I need to clean up this a lot, and then yeah.
Sounds good. Next is Viz and SQTT stuff.
This starts the exec to dispatch linker, and also the CLI exists.
Wait, what's the exec dispatch linker?
The liner in the web viz that connects the exec to the dispatch.
Oh, the lines. Yeah, the lines are very cool. Let me
Yeah,
switch to
reviews.
Viz equals 2. Why was RDNA 4 crashing? And are you confident that stuff's fixed?
I fixed it. I merged it. Yeah.
But are you confident there's not more issues like that?
Pretty confident.
You said that the inst number is telling you the number of cycles it takes?
Oh yes, I think they put it in the enum.
Well, I mean, that's so interesting because like when I was looking at those things for when I was labeling those things for RDNA 3, I was super confused and I almost felt like there was a bug because the loads in the stores were like slightly overlapped. Like the loads were like 0, 1, 2, 3, 4, and then the stores were like 4, 3, 4, 5, 6, 7. And I was like, why does a load in a store have the same number? This doesn't make any sense. But if it's the number of cycles, that's amazing.
Actually, it's only on RDNA 4.
I'm
Yeah.
pretty sure it's on RDNA 3 too. At least-
Yeah, they call it in different things. Maybe they just update RDNA 4, but
Yeah, I mean, it just feels like here, I'll paste something. Like here's like a viz wave pointing to vmem.
Mhm.
And it looks like those things are actually 2 cycles in vmem.
those VMEMs are 2 cycles. Yeah, could be.
Would be my guess, right? And I wonder what the instruction type is, if the type tells you it's 2 cycles. But yeah, I would have Claude try using the SQGT thing to get a fast WAMA. Like a fast WAMA gem. And like we should make sure the tooling is good enough that LLMs can like just do that with the tool. I don't think we should be thinking about how fast our gems are. I think we should think about how fast of a gem we can get in an hour with Claude. Basically, I'll make like an auto research repo that uses tinygrad, and then yeah, we'll give it a time and a flops target. See how far it gets.
I can play on its own.
Also, you want to move that tool from extra into main tinygrad?
Yeah, sure. I mean, like, I want to polish it. It's only 2 days old, so
All right. Keep when you feel it's good.
yeah. I'm considering I have the PR, make Wistia like this for humans. I'm considering removing limit and offset, and we were complaining about those APIs being.
Think about the API people really want.
You want to like pipe it.
Well, humans might pipe it to more or something, but LLMs aren't going to do that, and I'm not even sure humans really want to do that either.
So what would you want?
Not sure.
Okay.
Maybe
Yeah, I experimented it.
yeah, maybe limit and offset are okay. I mean, I would see how the LLMs use it, and I would play with it yourself, and just like find some happy compromise.
Yeah.
I like the arrow keys working.
Oh, the arrow keys just integrated. Yeah, the arrow keys existed for like 2 weeks at this point.
Yeah.
Now the links are very nicely. Like I want web this to lean into the visual cortex of the humans, and the LLMs can't worry about the details.
Yeah, I mean, like looking at this visually is so good. I wish the LLMs were better at that. How's SQGT on CDNA? Is it still unusable?
Oh, for CDNA, I merged the emulator.
Yeah, the emulator.
Emulator runs the admin gem. Yeah.
Cool.
Uh,
Well, how about SQGT for CDNA?
no SQGT work. That was new.
Yeah, like I don't know why it's the traces look broken. There's something we're missing.
Or it might just me that this is exactly how it works. And it's just a different architecture we're not used to.
Who says this is how it works? It just looks wrong to me. Like what I see is like one trace with one wave. Like it may only be one wave, but there's definitely more information in there about like the different subunits of the thing and how they're being used. Oh, also for the viz-cli tool, are the kernel execs still called devices?
I should probably call them like a generic. Yeah, they're called devices.
Yeah. I don't know. They're definitely not devices.
They're not devices, yes, but they use the same API. We'll figure it out.
Anything else?
No, I think that's it.
Great. Do we have any comma complaint? Have they upgraded to the latest and greatest Tinygrad?
They have not. Something that's slow. I don't know. Armand said he's going to take a look at this and try and give me something more reproducible. Because he was like, "Oh, this thing is slow," and then he ran it himself and said that it wasn't slow. Anyway, I don't know. So I'm going to try and be on him a little bit more to give me something that I can actually work with. To figure out what exactly is blocking them, but it's some automated step in their CI that says this thing is slow, and then I don't know exactly. I tried to look into it a little bit, and it seemed kind of complicated. And I was like, okay, it would be a lot easier if they said, okay, like here's the thing that's slow, here's the issue. So I'm gonna try and get that from them and sort this out.
Okay. I think Flata, you want to say something about your training?
Not a whole lot. Just got the training loop going on. I got the first step, but I think I used Claude and just some optimizations. I think I used some batched optimization for the parameters because there was a lot. So I'm still cleaning it up and looking to see if I can put up a PR for it.
So this is training Stable Diffusion or Flux.
Yes, a Flux. Yeah,
Does it have attention?
it does.
You want flash attention? How slow is the
Sure.
step?
I haven't measured it yet, but it's still pretty slow. Probably like over a minute, I think. Probably even more.
Over a minute. And then how many steps do you have to do?
I think until it converges, there's a metric there, so you kind of have to stop like at a certain amount of steps, and then you can evaluate from there, and you have to
Yeah.
kind of keep going.
But I mean more for the other ones. What have you seen? Like the compared to the other, how long did those ones take? How many steps?
Oh, the other reference ones. I had to take a look again. What NVIDIA? I think NVIDIA has one for sure on that, but they had like bigger clusters.
Yeah, just like figure out the number of steps, figure out what steps we need to get a reasonable time. And then do you actually want to try to submit for this round?
Probably not this round. I feel like it's too close. I think the next round. I think it's probably around October or November. I think that one is probably more suitable.
So this round is May 11th. Next is probably October, mid-October. They have a date. I'll find it and post it later.
We need to pray they don't remove 405.
I thought they would, but I don't know. And what else? I think Bounty, the Queen one looks good.
Yeah,
It just need to be upstream cleanly.
Yeah, I mean, we gotta. What are the other tools? Like, what if I just Google like right now, like Quen 3.5, 35B, Spix Halo, talks per sec. What do I get?
I imagine you will see very similar thing on the SGLAN and BLLM. Like they either just don't work or they didn't optimize for it.
They're getting 20. Oh no, that's not with 4. Oh, Yeah, they're faster with Q6 than they are with Q4. I think we're using Q4. It looks like their fastest one is 43 tokens per second. So if we're getting 48, that's great.
Great. So can we go through the old PRs and people close some of the old stuff? We have a lot of PRs now.
Sounds good.
Okay.
Go to PR. That's
great.
awesome. That's from 14 days ago. Wait, we're actually going to win.
Yeah.
We got something.
Great. Let's find a way to upstream this. We probably need to decide how bloated we want the .py to be.
Yeah, it's not. I mean, it just looks okay. It's just that other thing needs to be split to a different class. We shouldn't have
Yeah.
one class that's doing both types of layers. Yeah, and then we should quickly see which is faster, the Q4 or the Q6.
Okay, sounds good. I imagine B1TG would listen to this recording, so just put whatever update or questions you have in terms of high-level design, if you have any in the corresponding channels, and we will resolve it there.
Well,
Okay.
let me look at that one. Oh, that's amazing. People might actually use this.
Great, sounds good. Open issue.
Oh, also, when 27B is going to be slow, but it's not mixture of experts. But apparently that one does really well on like Claw Bench.
Oh yeah, 27 performs much better than 35 because 35 just has too little active parameters.
Yeah. Oh, it was number one. Oh, GPT just overtook it. But the number 2 model on Pinch Bench after GPT 5.4 is Quen 27B. So we should make sure we got that one working too.
What's
That one? That one also might be a really good one to run on Tinybox Reds.
Interesting. Okay, great. Sounds good. I think that's it for this meeting. Thank you, everyone. See you next week, same time. Bye-bye.
Bye.